of this meeting. As you can see, we have our beautiful logo on the slides right here. It looks great. So getting started, 1 second. Joel, did you say that you want to record this meeting?
Yep, and it is recording.
Cool. Yeah. Okay, so we'll start off, we'll have a little icebreaker. Then we'll talk about the development process a little bit so that we can start looking at more long-term planning. We'll have a short intermission. And then afterward, both teams will present their research, what they've done so far, and we'll go into breakout rooms to just really ask some difficult questions. So what Joel and I were planning is like the teams kind of split up a little bit. So some members of the Power Sat go over to the Mushroom Sat and vice versa. And that way we can get some input from the opposite team and really ask difficult questions. And then next week, we will bring in some experts and we will make the final payload decision. First things first. Oh, that is an old icebreaker. That is, I thought we had changed that one.
Dylan Smith has an excellent suggestion for an icebreaker.
What's Dylan's suggestion?
Dylan, do you want to say? I can't see. I don't know.
The best way to break ice.
I think that's a good icebreaker. All right. Joel, do you want to handle, are you set up in a way you can handle the breakout rooms?
You are the host right
I'm
now.
the host. Okay, I can handle the breakout rooms then.
Okay.
Maybe. I might have to stop sharing. Are we thinking like maybe 3 breakout rooms? No, 4. All right, I invited you all to breakout rooms.
How's it going?
Hey, Michael. How is everyone?
Good.
Good? Yeah. Evan, how are you doing today?
I'm pretty good. Yeah, nothing much going on this week.
Mm-hmm. That's how it goes. Well, I guess right into the question. What are the best ways to break ice?
Chuck it into a black hole.
A black hole. Interesting. That's certainly one way to approach it.
Break in that case, or just kind of get spaghettified and destroyed. I guess destroyed is kind of like breaking it.
Yeah. Huh. I guess like that honestly might be the best way because it probably like changes the atoms of the ice as well. So you're like literally destroying it to the atomic level.
Can't really break it any better than that, I guess.
Hmm. I don't know. I think probably the most fun way to break ice is to throw it at things. I don't know. My roommates, like we have a fridge with a freezer with ice, and my roommates and I just like throw ice at the sink and it explodes. I don't know.
Everyone does, yes.
Yeah, of course. I don't know.
Like an ice bomb.
Exactly, yeah. No, that's honestly, yeah, that sums it up perfectly.
Terrific.
Are there any other like creative ways?
I'd say just a good old hammer.
Mhm.
You know, just smash the ice.
The classic. Yeah, of course.
Classic.
Throw it in.
Firecrackers break ice. I think.
It's
I
valid.
assume.
Hmm.
Could throw it in an oven.
Or like a volcano or like a nuclear reactor would work too.
You know those like the fission reactors, how they have that big pool of water where they keep the rods in. If you froze them, what would happen? Do you think it would just melt it back into water at the end of the day? Like,
Well, yeah, well, don't they have like the giant pools because of the pressure that they create at the bottom? 'Cause,
they have the giant pools because water is a really good way to stop beta radiation.
mm,
Like you could swim in that pool and be okay with
yeah,
it active. You wouldn't be great. You get
uh-huh.
cancer eventually, but you wouldn't die right away. So I mean, that's a
That
upgrade.
makes sense. Hmm.
Yeah,
But then what's the temperature at the bottom?
I think it's pretty hot, right?
Yeah.
Like I think it's boiling the water at the bottom, but not the top.
Reasonable. Hmm. I don't know. So like just throw some ice in there, I guess.
It's called a pool type reactor,
Pool type.
also called swimming pool reactors.
Yeah, that sounds like a fun place to go swimming. My
It says
next
the layer of water directly above the reactor core shields radiation so completely that operators may work above the reactor safely. This design has two major advantages. It's easily accessible, and the whole primary cooling system, i.e. the pool of water, is under normal atmospheric pressure.
Hmm.
Interesting. And it doesn't get that hot.
really.
Interesting. Oh my god, and they're 9 meters deep. I thought it said 9 centimeters. They're 9 meters, 30
It's
feet.
a little bit of a difference, just like
A
a
little bit of a difference.
scale of 100. Um, yeah, I don't know. Are there any other cool ways? Oh, looks like we only have a minute left. Hmm. All right.
Biting it.
That's a good one. I don't know. Evan or Dylan, do you guys want to be the ones to share with the group kind of what we talked about? Some good ideas?
Sure.
All right. Yes, you both can probably chip in some of what we talked about if you're good with that. But yeah, I'll see you guys on the other side.
Because like in malls, they have to sign like a contract saying like no other place of X food type can go in. And Subway moved in, and it was a hot dog place that was in before. So they went to court over whether Subway can move in because it's a sandwich place, and the hot dog place wanted to be considered a sandwich place. And they ruled in favor of the hot dog place. So technically, legally speaking, hot dogs are sandwiches.
Dang, okay.
Would a quesadilla be a sandwich, like two pieces of two tortillas and like meat and cheese in the middle?
Maybe.
Yeah, I agree.
I mean, I think tortillas are, I don't know, they're different than bread. Like they're very much,
Bad bread. You know,
what'd you say?
it's just bread, but flat and bad. That's all it really is. You know,
Have like corn-based tortillas. Technically, it's not based in flour, so does it still count?
Well, you could have cornbread too, so probably yeah.
I make all my bread out of corn flour, so
Uh,
Yeah, a few days ago, a court in Scotland deemed that Subway sandwich bread isn't actually bread.
What happened with that one? Why did they make that decision?
Because in Scotland, there's some super old law where you can't tax bread. So Subway was like, well, we shouldn't get taxed for our bread. And then for some reason, they had to go to court. And then the Scottish law system deemed that Subway bread isn't bread because there's too much other stuff in it than just bread ingredients. Like it's so diluted with like preservatives and really high sugar content that they're like, this isn't bread. This is just edible food. I think it's hilarious.
That was pretty awesome. Yeah, imagine being at a sandwich place and they're like, "Hi, you don't even serve bread."
Sad bread imitation.
That was a pretty decent icebreaker. Moving on. Here's the project timeline again. But hopefully after this we can begin looking at this in kind of a different way, because one of the things I want to do is talk about the development process. So Karen, obviously you're kind of our resident expert in this field. So if I'm leaving out anything or you think that I should say things differently, please jump in and correct me. But I'll do the best I can. So basically there's 6 basic phases to the development process. So the pre-phase is kind of just figuring out the mission requirements and like figuring out what you want to do. Phase A is all about planning. Phase B, you start designing it. Phase C is kind of final design and fabrication type stuff. Phase D is assembly and launch. And then the last phase is kind of just everything you do post-launch. So in a little bit more detail, why do we have a development process? So the main 2 reasons we have a development process is to keep everyone on the same page, because when you're working on a project, especially a large project like this that has sort of multidisciplinary coordination with like electrical and mechanical and software, the development process that has a timeline really helps keep everyone on the same track toward the same goals. And it also allows us to schedule time for mistakes. So without a development process, if we didn't have like a clear calendar of what we were going to do and like clear breakpoints and checkpoints and stuff, we might hit snags along the road that we weren't prepared for, and that could totally derail our schedule. But with the development process, we plan for those setbacks. So just a little bit about the first phase. So the pre-phase A is like the first thing that you do. So this is where you start the mission, you define the goals and the requirements, you maybe start like picking the alternatives for the missions. For us specifically, this is a little bit of where we are right now. So we're picking our payload ideas. We're trying to narrow them down to fit the mission requirements. Obviously, we aren't going to get to define all of our goals, but because of the rules from the CSLI, we'll have to align with NASA's rules. But we also do get to define some of the objectives that we want to achieve in terms of like research and what data we want to collect. The next step in the development process is phase A, which is all about planning. So in this one, we have what's called an SRR meeting, which is schedule, risks, and requirements. The schedule, risks, and requirements is basically just making sure that we have everything planned for and we have a clear timeline, and that, like I said before, we schedule time intentionally for setbacks and mistakes. It's also a time to make sure that the schedule is reasonable for everyone. For example, in a company or like in a project like this, the electrical might say, hey, I need a week to work on this project. Let's make this part of the project a week. But then mechanical might say something like, hey, I can't do that in a week. There's no way. Can we have a month for this? And then like software might say, oh, a month, I actually need like 6 weeks on this part. So making sure that we have a full team schedule meeting will allow everyone to have the time that they need so that we can really work together and have a cohesive schedule. For us specifically, what this means is that we develop a timeline of proposal writing and that we get a strict schedule for the project development. It also means that once we choose our payload, that we develop some of the risks of that. So we'll talk about things like what happens if it goes wrong? What things do we really need to be mindful of? So that's the first phase where we plan everything. The next phase after planning is the actual designing part. This is slightly more fun in my opinion, but this is where we start kind of a high level design. One of the checks that we do is called the PDR. That's, I think, John, you said that's like October 24th, is that right?
Which John? Me?
Yeah.
Yeah, October 24th. And just a note, we're going to try to see if we can safely put everybody together physically.
All right.
And we'll figure out where soon.
Yeah, that's awesome. So that's the PDR. And the PDR stands for Preliminary Design Review. Basically what that's going to be is kind of a high level checkpoint on whether our concept for our design is sound. So we'll come together with the other two teams and we'll compare ideas. And this is just sort of a checkpoint before we really start getting into the detail part of the design. For us specifically, like I said, we will have our PDR on the 24th. And it means that we're kind of a broad design phase. So you get like our basic ideas down. Just as an example, our PDR for our high altitude balloon, we did that before we ever made any sort of CAD models or anything. Basically, it was just a presentation of all the different parts, like diagrams and stuff for each CANSAT. And so we checked in with some experts on that and made sure that we were good to move forward. So that's similar to what we'll do with this CubeSat project. The next stage after the PDR is the actual final design and fabrication.
John?
Yeah.
Excuse me for interrupting. Can we go back to the PDR for a second?
Yeah.
Just so everybody sort of physically, it's going to be hey Ben, we'll introduce you in a little bit, but how long did your PDR take in Florida?
How long did the meeting go?
Yeah.
The meeting kind of went from, I want to say about 9 o'clock in the morning to roughly noon, but we were presenting like 6 different ideas.
So, probably at least a good half day for everyone. And right now we are trying to see if we can meet at either the museum, the SAC Museum in Gretna, or the Innovation Center in Lincoln. So we're trying to see if we can schedule. So I would say if you guys could, we'll get you some more detail, but if you have any conflicts on the 24th, let Joel and John know, okay? But we're gonna make it we'll make it fun. We promise
Absolutely.
Joel and John won't scare anybody. Right, Joel?
Yeah, you got it.
Absolutely.
Hey, thanks, Ben.
Yes, thank you for setting all that up, John. We appreciate it. So that's the PDR. After the PDR, we move into phase C, which is the final design and fabrication. One of the key checkpoints in this is called the CDR, which is the critical design review. The critical design review is basically like, it's a more advanced version of the PDR, and it's kind of the final checkpoint before we start really building and testing everything before launch. So what will happen is we'll complete a really detailed design of all our components. We'll 3D print or fabricate or do whatever we need to do to manufacture these components. And then like we'll look at them individually and test them with the critical design review before we put them all together and integrate them. For us specifically, this means that we need to develop like detailed designs of all our components. So we might split them up into like, you know, the solar panels or the fungus or, you know, the different parts of the module. Evan says if we need to 3D print, he has 2 printers. That's awesome. Well, there's also a ton of 3D printers on campus and everywhere else. So yes, we'll have plenty of resources to do whatever we need to do in terms of fabrication. Kind of like I mentioned, this is the components that we're testing here are still in modules. This is before we put everything together. And the point of this kind of the CDR is to allow us to test all our components individually. So we make sure that they're sound before we start making them an actual system. For example, our high altitude balloon project with this, we have different modules of like the truss, we have a heating system, we have the electrical system. And so we haven't done our CDR yet, but when we do, it'll be testing all of those components kind of individually and making sure that they all work on their own. And finally, phase D, which is the most fun part of the process, the actual assembly, the integration test, and the launch. After we get the CDR done and everything's ready to be integrated, we'll put it all together. We'll make some kind of systems checks on it. We'll do a flight readiness review to make sure that it's not going to fall apart. And we'll see if everything works inside the actual cube. Finally, after we launch it, there's kind of a decommissioning process. So on a more industrial level, like with NASA, there's a lot of like decommissioning reviews, and like they have to assign parts for the next project. They have to analyze and archive their data. For us specifically, this is going to be the time where we're going to collect the data from our project via whatever communication we have. We're going to keep talking to our CubeSat. We'll probably have a little pizza, and we'll prepare to go to space the next time. Are there any questions on that or things that I missed?
What kind of pizza?
No pineapple pizza.
No pineapple. See, I was gonna have one pizza that was just pineapple, and then like maybe a hamburger, pepperoni, cheese. I don't know, whatever you guys think.
I think the only other thing is on the post work that analyze and archive data. We may also be required to do a final report on everything we've done.
Okay.
Just to one, indicate whether our mission was successful, and if so, what we found out from it. And then that'll help inform future missions so that it's useful to everybody.
Yeah, absolutely. That'll be, I can't wait to get, like, to actually getting data from this thing. It's gonna be so cool. Anybody have any other final thoughts or questions about the development process?
I don't know. It seems like we need to do some more decisions on what type of pizza dough eventually, because it seems like there's a lot of different ideas for the type of pizza in the comments.
That's my
right now.
fault. Sorry.
No.
That's my fault.
I mean, we could have multiple pizzas, you guys. We don't need to have just like one pizza we need to choose.
A fun guy that eats pizza.
And we can get more than one pizza.
Can I ask everyone that can turn on their video to turn it on? So if I meet you in the street, I know who you are. And then also there's a couple of folks who I can see their fans running, but not their bright and shiny faces. So I think Caleb and Casey, I can't see you. That way everybody sort of knows who you guys are.
Absolutely. Yeah.
Mm-hmm. Yeah.
Don't have to do it for long, just so we can take a picture.
Mm-hmm. Absolutely. And especially when you're talking with anyone, if you're talking to the group or you're talking in one of the breakout rooms, it helps to be able to see each other, just for team building purposes and just getting to know each other, like John said. Both Johns said, actually. Stuffed crust is a requirement. That's a
It is. Stuffed crust is good. If your pizza doesn't have stuffed crust, it's like an automatic 5 out of 10 deduction. Like you can have a decent pizza without stuffed crust, but in order to be great, you need stuffed crust.
Absolutely. Well, it looks like you have some debate about that in the comments. We'll have to talk about that later. But for now, to
Joel, I was going to say, Dylan Smith, you have your hand raised. Is something about the pizza debate? Do you have a question about something? No? Okay. Sorry, as you were, Joel.
Absolutely. I did not see Dylan's hand was raised there, but that's good to see that. The only other thing, so I know our team has had a little bit of interaction with the Florida team and the North Carolina team. I know some of you were in a big group call when we were discussing potential payload ideas like several weeks ago. So you probably haven't heard a lot or seen a lot of the Florida team or the North Carolina team, but we're working on that a little bit, trying to get a little bit more communication between the teams. And I know Ben said a few things earlier, but Ben Purvis is from the Florida team, and he's going to be acting as kind of like an intermediate person between our two teams to kind of give updates on the Florida team and sit in on some of our meetings, so the Florida team knows kind of what we're working on, and all of that. I don't know. Is there anything else you want to add, Ben, or do you want to introduce yourself a little bit more?
That was really it, Joel. Thank you for that.
Yeah, absolutely. Well, I just want to say welcome to the call, of course, even if you were welcomed a little bit earlier. But we're glad to have you and welcome some more collaboration between our teams. Yeah.
I see you guys are all still going strong on the pizza. Maybe this needs to be our breakout question for next time. You're gonna really hammer down on this.
Does anyone have a question for Ben? Ben, were you around for the 2018 launch?
I was at my school, but at the time I was not involved in the CubeSat building program. So I got to watch the launch, but I had no idea what it meant at the time. And then once I finally got involved in the program, I realized that was a really big deal.
Right.
How did it feel?
At the time, I didn't really know what it was, so I thought it was just another launch to space. But once I finally figured it out, I wish I had knew more, because then it would have kind of been a lot better of a moment.
That's great. Thank you.
Absolutely. Yes. Well, thank you for being here, Ben. I think we can move on a little bit. I had an intermission, but it's only like 10:30. So, Joel, do you think that we should move on to presenting research?
Yeah, I think it'd be great if we could present research. Then we can go to our intermission and come back and do a lot of discussion in breakout rooms.
Okay, awesome. So between MushroomSat and PowerSat, is there anyone who wants to go first?
We can go, I guess.
All right.
All right.
Do you want to share your screen, Elsa, or would you like me or someone else to?
I can.
All right, sounds good. Thanks.
Okay, so we each did some respective slides. So this one is, we chose our specific species of fungi this last week, and this one's called Cladosporium sphaerosporum, something like that. It's a radiotrophic fungus that can use radiation as an energy source, which generally reduces radiation in the area. It was found in the Chernobyl site, along with other very similar species and subspecies. And this, since it can eat the radiation, it could potentially protect astronauts and like radiation-sensitive equipment in the future. And an experiment was done on the ISS using this same species that we chose. This wasn't my slide, so whoever it is can share.
Okay, so what is our experiment? While in space, astronauts deal with lots of radiation exposure, and obviously radiation harms humans, so we want to see if there's an effective way to block that. First, we will need to see like if our fungus can actually grow in space, or like how we would do it. And one idea we had in the middle of a paper on an inch that measures radiation and grow the fungus on like the outsides to see if like the radiation decreases. And if it does, that could introduce a lot of possibilities for space travel. Some questions you would have to ask is how could the mushroom grow in space? And would this be about, and how easy and or difficult it would be? Oh, that's it.
All right. This one is like, why should NASA pick this experiment? And this research could help protect future astronauts from radiation. It could be a cheaper and renewing source of protection for astronauts and radiation-sensitive equipment, because the stuff we use now is really expensive, and if we could just grow our radiation protection, it would be much cheaper. And this is radiation shielding that could get exponentially stronger over time instead of weaker, because it'll just keep on growing, and most things would wear down, but this stuff would just keep growing. This one is my slide.
I think this is mine. So how would we study this, or how would we measure like what we want? We need like a piece of equipment capable of measuring radiation inside the CubeSat. We want a device that can hopefully measure all three types of radiation, and something we can easily get our hands on, and like it's able to transmit it back to Earth. It was really hard looking into what type devices would work, because I'm not too well versed in radiation. So it would really help to reach out to companies who are like well knowledge in the subject.
Yep.
Unless Joel has anything else to add.
I think you pretty much covered it, Gavin. Yeah, we did some initial searching, but didn't come up with a ton of, full radiation spectrum with all the different types of radiation. But we found some initial like UV and so ultraviolet and infrared sensors that we can easily buy. But of course, we want something, probably a little bit better than that we might have to especially look for.
And can you talk a little bit more about that ISS experiment? Like, what did they find out from putting these mushrooms on the ISS?
So with the article that I saw, it said that it was still like it happened kind of recently, and they haven't like posted like exactly what happened yet. It's right at the bottom of the Wikipedia article for it, and there's some other articles on what they did, but there's no like end of experiment stuff.
Okay, absolutely.
The only other thing.
Or
Or
What'd you say?
Oh, I saw Ben's hand up. I have a question, just if you can help me understand what we're trying to do here. So there's radiation in space, and we're trying to eat the radiation in the CubeSat. Will our CubeSat, are we trying to measure whether, will our CubeSat be constantly absorbing radiation, and we're trying to see whether by having that fungus, the amount of radiation we have in our CubeSat is lower than outside, or will we have a CubeSat that is sealed where the radiation can't penetrate, and we'll be looking for that number to go down? Because it's two pretty different measurements, and whether we have to track, like, if the radiation continues to come through, then we probably kind of have to track what the radiation is outside versus inside, right?
Mm-hmm.
So I'm just wondering what we're exactly going to be measuring.
Probably wanted to figure out exactly what we'd be using to measure it, because Joel and Captain didn't find that much, because there's not that much radiation stuff you can just find online. So we probably wanted to see what we had available and see how the mushroom itself could grow, if it what it needed to survive in space would probably be a big factor of figuring out what we'd be doing exactly for our experiment. So yeah.
So
I
are we
would say
interested in the mushroom surviving, or actually measuring a change in radiation?
We
I
kind of
would
want
say
to
like your
change in radiation, yeah.
Or both, like maybe, I guess, because if the mushrooms don't survive, there won't be a change in radiation. If the mushrooms do survive, and then the question is there a fixed amount of radiation where we can measure it going down, or is there constantly more infiltrating, and the relative radiation inside and outside is reflects the mushroom's activities, right?
Mm-hmm.
Mm-hmm.
Yeah. This type of fungus.
What did you say there, Ben?
What made you want to pick this type of fungus?
We kind of chose it, we had a couple different ideas. We had to choose, since there's so many different types of mushrooms and things, we could have experimented on a lot of different things. Like we could have used an edible mushroom, or a mushroom that could have been used for medicine. But we chose this one because I think it would be the easiest to measure radiation over how the mushroom is surviving. And we chose this, we had 3 species that were really similar. They all had weird names like this one. And we chose this one because, honestly, probably because it had the most information about it, other than the other 2 species, which had a lot less information. And they were all pretty similar, so it didn't really matter which one we chose, but this one had a lot more information than the other 2.
Okay. Michael, did you say that you had something to say?
Yeah, so Karen, you were talking about, are we seeing if it's surviving weather, decreasing radiation? I don't know if it's this exact same type of mushroom, because I guess I didn't look super far into it, but I heard about it. But I know that there was research posted where I think it was the same one, because they found a mushroom that was growing at the Chernobyl site, or a fungi rather. But so with the previous experiment, they did do the testing to see if it can just survive in space-like environments, and that it could. And then they did some minimal radiation shielding testing, and they found it was something like a 2 millimeter thickness of a sheet of this fungus decreased the radiation on the other side by 7% or something like that. But that was 2 millimeters thick. So they ended the research saying essentially more research needed before we can say anything. So as far as the question of can it live in space-like environments, that test was already done. I don't know the details. You need to find that paper, obviously, but I know that they did a test with that, and they said yes, it could. There's just now that they since opened up the floor to well is it going to be make effective shielding. But yeah, then what Karen said earlier about how we need to figure out a way to measure the before and after, right? So that I reckon would probably be pretty useful. But I just wanted to interject and say that they already know that it can survive in space. Now it's just a matter of how effective is it as a radiation shielding technique.
Mm-hmm.
Okay, so
Yeah, I
there-
think I've read that article before, and it's like exactly what you said.
so there should be information then on what we need to do to make sure it does survive in our CubeSat.
Yeah.
We could reach out to them, maybe.
Yeah.
Whoever did it.
That'd be an excellent connection to make. My question for Michael and anyone else that has read the paper, I read the paper, but it was several weeks ago, and to my knowledge, the way that they tested if it could live in space was within the International Space Station, within like a controlled environment. Is that correct to your guys' knowledge, or were they like out in the boondocks of space, like with the temperature fluctuations and all of that?
I think it was in the ISS.
Yeah.
So we need to test the space environment then, because we won't have the controlled ISS environment.
Yeah. I believe that's kind of what we were thinking with the payload. Because like there has been the preliminary testing, if it can survive in space inside the International Space Station, but being a more like dangerous environment for the fungi with the temperature fluctuations, especially. I think that was one of the big things.
Oxygen would be different, and
Certainly, yeah.
The paper that I had originally read, like Joel, like a month or two ago, I have the link for it, so I just pasted it into the chat. If anyone wants to look at that, I think with the one that I read, I think their plan was more like growing a radiation shielded like building on Mars, or growing radiation shielding plates that are alive and replicating. So I don't know if at least this one intended to have it, like Joel said, in the boondocks of space, as opposed to on the inner walls of whatever their craft was. But the paper that I had read anyways, I pasted into the chat so we can look at that later if anyone wants to.
Certainly. We'll have to do some more research and double check some of the reading there. But I think to finish off the presentation, since we've kind of gone and asked a bunch of questions, which is great, I think there's one more slide that I think Dylan and Gavin and a few other people wanted to share about.
And which one is left?
Okay.
I
Yeah.
think that was mainly Alyssa.
Yeah, that was me. I wrote that down. I just looked up sandwich on Google and put down the definition.
Well, no, you're wrong there, because a hot dog wouldn't be a sandwich if it only has one piece of bread. Like
Well, it is kind of two pieces of bread.
No,
there's
it's
not.
one
It's
connected
continuous
piece.
of bread.
Well, if
Wait,
you
John,
unconnect
wait,
them-
you've been to Subway. You cut into like the way Subway bread is like a hot dog bun. Is that not a sandwich?
Michael,
Yeah.
we're not talking about Subway. We're talking about hot dogs.
well, they're so
What
simple.
makes a sandwich a sandwich?
It says right there 2 pieces of bread. So I think if you cut the hot
So
dog
Subway
bun,
sandwiches are sandwiches, is what you're saying.
Yes.
what about?
I mean, they're not really
open
bread,
sandwiches?
though.
According to Scotland,
One piece.
Not in Scotland, they're not.
we're in America. We eat terrible
This
food
is
here.
America.
That's different here.
It's a sandwich here, but not in Scotland.
That's confusing.
I'd say no to hot dog.
If you cut the bread with the hot dog. then I
Okay, but who does that? Like, what kind of psychopath just cuts their hot dog bun?
Well, sometimes it rips. Like sometimes you just can't. Like if you have a terrible hot dog bun.
Okay, fair enough.
I love the discussion, and I love that we're passionate about sandwiches. That's great. But we want to make sure that we leave time for the power set to present before the intermission
Yeah.
too.
Also, before that, I was going to ask, maybe this is a good time to ask what Florida is doing and like what their selection process was.
Certainly.
Ben, if you can help us with that, maybe.
Right now, we're just really just going over ideas of what we should do. We have an idea based on growing hydrogen. We have several other ideas, but I'm only on the hydrogen idea. It's a bacteria that eats radiation. So we're pretty much just going over ideas, how we're going to make it the same process you guys are going through.
Awesome. Do you have a plan to choose one of those yet?
For the past few missions that we've been trying to eliminate, get down to one, what we usually do is just we have a Google spreadsheet almost, and we'll have everyone in the class or the program vote for which one they like, and whichever one gets the most votes, that's the one we roll with.
Okay. Yeah, thank you, Ben.
Hey, Ben, I also heard that you guys were looking at a bacteria that's eating plastic.
I'm not sure. There are several different ideas that we're working on. I'm only working on one of them. So
Which one are you working on?
I'm working on the hydrogenotrophs.
Cool.
So, Ben, how many ideas did you say you have right now? Like 6 or something?
Well, there's 3 different classes, and I know actually somewhere around 10. Which those ideas then have their own subsystem. So we have the basic idea, and then we have a subsystem for almost each idea.
So those classes are going to all come together once you choose one, or how's that going to work?
We're all the same class pretty much. It's just we meet at different times, so not everyone in class. So when it comes to voting during that class, you'll just take the vote, and whichever one gets the most votes.
Yeah, that sounds like a really good. That sounds like a good way to do it. So moving on just a little bit from that, and well, I guess I should ask you, Joel. Do you think we should do the power sat before the intermission, or do you think we should take an intermission?
I think it'd be good to do the power set before the intermission, and then intermission, and then we can do some of the breakout rooms to discuss.
Okay. So is there anyone from my little power sat team that wants to share their screen?
I can.
Yeah, sweet. Evan, what's the thing you have in person?
So we were talking about the origami solar panels.
Yeah.
So I made this little sort of demonstration thing. So it starts as this tiny little, about 1.5 inch by 1.5 inch thing, and then you just pull on the sides. It expands into a larger.
Okay, that's pretty cool.
Yeah, that's awesome.
Yeah, so that's what I got.
Yeah, that's excellent. I think we could probably use something like that.
Can you see the screen?
Yep.
Okay. I can start, I guess. So first off, I'm pretty sure you don't actually pronounce it perviosquite, but that's what I'm gonna say it is. So perviosquite for the pillar for the CubeSat. This is basically just the overview, which would be our, yeah, but basically what we put on the slideshow. So our experiment would be to measure the output of energy from the perviosquite solar cells compared to normal solar cells. We would measure the lifetime of perviosquite cells. Possible methods would be test an array of half regular cells and half perviosquite, and look into folding arrays for more area. Here's just some general facts about perviosquites. So yeah, on the right, that's a picture of, I think, the structure of it. So yeah, the mineral of perviosquite is calcium, titanium, oxygen 3. Yeah. To the next slide. What the perviosquite solar cells do, they are meant to increase the amount of sunlight power to 32.2%, which is collecting 19.2% of light, but it's only a power boost of 5% because you can't convert all of it to energy. It's around that. They cause silicon to absorb blue and purple photons. Basically, they make regular solar cells more effective and efficient. Well, they're more efficient than those. A nice thing about perviosquites is that they have a small environmental footprint, so they require a whole lot less to make than regular solar cells. This should just be a list of what we need for the perviosquites and just what we need in general for the CubeSat. Here's a chart. In 2013, the perviosquite solar cells came out and have since then become the second highest in energy. Here's the advantages of the perviosquite solar cells. I'll read off a few. They have a small environmental footprint. No matter how they perform in space, we are still getting important research. They're thinner and lighter than normal solar panels. They are being looked into a whole lot right now, so it's very likely to get accepted. And it's being noticed by a lot of people. I forgot to move the graph on the next page. It's talking about the graph that I showed earlier. Here we have challenges on the left of what would be the challenges and solutions on the right for them. One of the challenges is that perviosquites degrade quickly in oxygen, high temperatures, and in too much light, which, yeah. But if you encapsulate them in plastic, it helps make well, keeps out the oxygen from degrading it and just helps it work better. The perviosquites, they're fairly new, so there's a few sites that you can buy them from. Then we could probably also make them ourselves if we wanted to.
Yeah, just something to add to that. So there are some places we can purchase them, but more than likely what we'll be doing is like making our own modifications to them. So one thing that we found is that you can use something called like spin coating, where you basically just take a little bit of like the droplet, like a dropper with a chemical in it, and you just like spin it onto the really thin solar cell. And I think that's something that we could get a machine for that for fairly cheap if our chemistry department here doesn't have it. But manufacturing is very feasible.
Yeah.
Does anyone have any questions about perovskites?
I was just gonna add, just clearing up in case anyone was confused. Our mission would be wanting to see if it would make the amount of electricity that you get from space, or I guess from solar power, if we can enhance that. And it would also be testing to see if their lifetime is any better than the most common one we use right now. Since it's so new, there's not much on it. So sending it into space on a CubeSat I think would be a good idea because it would cost less, and our control would be having half of the CubeSat covered by the normal, so we can tell what the power amount is.
Mm-hmm. I have a question for some of you guys. So you said these are like fairly new panels, right? To your knowledge, have they been to space before, or has there been any other similar testing to what you are proposing?
I was right here. That I could not find anything about people sending them to space yet.
They used, I think there is like one mission where they might have used them as for like a rocket or something. I don't know if it stayed in space the whole time. Ben, I think you raised your hand. Is there something you want to add or ask?
Yes. So how fast do perovskites degrade?
So that depends on their environment. Some of the key stressors are oxygen and light. Well, oxygen, moisture, and light, which obviously light is a little problematic. Oxygen and moisture is not really going to be an issue, but I think originally, like the first perovskite cells degraded within like 200 hours or something. But after they did some more testing on them, one of the papers I read about encapsulation and making them more stable actually got them to last for like 450 days. Well, no, actually more than that. After 450 days, they hadn't lost any of their efficiency. Gavin, you also raised your hand.
My question is, what's the point of taking it in space? Like, why do we want to take it into space? Can we see which one's more effective on Earth? Or is there a reason we're taking it to space?
I can answer that. It's just because NASA's had a lot of issues with solar panels staying efficient in space. It's lasting, but it's not lasting for long enough for the ideal length. And so by us testing in space, that would be a good appeal to NASA, being like, you have an energy problem, we have a potential solution, we'd like to try this out in space. Because it's just in space, I mean, basically stars and sun is the only light you're gonna get. And so kind of testing it on Earth and testing it in space, it's two different atmospheres and things like that, so.
Keegan, would the usage have any benefit on Earth as a source?
Yeah, I mean, if we can get them to be more efficient in space, like we can get more advanced solar panels, then it'll just be an upgrade to what we currently have on Earth.
Sorry, Keegan, for some reason we couldn't hear you.
No, it's fine. John basically explained what I would have said, so.
Okay.
And I think, so we had a video at some point, but I think one of the things they mentioned, Robert, I think you said something about the lead in them.
Yeah.
You want to say something about that?
Oh, yeah, sure. Basically, and I'll go on this one. What is this? There we go. On that chart there, the pervious gate structures are made from something combined from column A, column B, and column X3. So you combine those to make the pervious gate structure. Most of them are use lead because that's the best one right now, but it requires a very little amount of lead. I think on the video I watched, it said like 0.0007 milligrams of lead are in it.
Yeah, in comparison, like car batteries have a lot more.
Yeah.
Kind of the point of that was just because there's been some, well, like one of the things you might find if you look into these is that, oh, like they have lead in them, they're harmful, but actually it's not that big of a deal because the amount of lead they have is not.
Yeah, your car battery would be more dangerous.
Any more questions or anything?
I just did a quick Google search, and it looks like out of Germany in August of this year, August 12th, it looks like a sounding rocket, but they took perovskite and it said they just say organic solar cells. They don't really say what beyond that, but they put it on a rocket. It looks like a sounding rocket that went up to 240 kilometers and came back down. And the purpose of this mission was to test if it could survive the trip up, and it survived. So I don't know how much that means for us, but in August, this school in Germany said that they wanted to see if it could survive the trip up there, and it did. So I don't know if that's important to us, but we don't need to ask that question apparently because they already fixed that.
Mhm.
So,
It sounds like we could capitalize on the next logical step for the research of this panel. But it looks like Gavin has another question.
I don't.
Okay.
I guess I should take my hand down. There.
Yeah, I just wasn't quite sure there.
Okay.
Yeah. I don't know. Does anyone else have any more questions for the power team?
All right. Well, if that's all, then I think we can move on to the intermission.
Mm-hmm.
Sound good?
Yeah. And then we will come back and have some great discussion and ask some, difficult questions to make sure that our payloads are feasible and all that. So get excited.
Yeah. Those are both very good presentations.
Certainly. I just have to say, John and I had talked a little bit about some of the presentations, I think last night and the day before, and we were all, well, I guess everyone on the AXP team that saw it, and especially John and I, when we saw your presentations, we were very impressed with a lot of the research that you guys did this week, and I'm really excited to see what else that we can do this week. So proud of all you guys, and great job this week.
I second that. Yeah, I didn't see this picture.
Yeah, I added this in kind of at the last second. So the AXP team, we met with our mentors that are in industry at Ensign Bickford Aerospace and Defense, and they kind of talked to us a little bit of the development process and how when you're going through some of these reviews, it can be a little weird and a little, you might want to get kind of defensive about the research that you're trying to do, that you have done, and that it might be, it's easy to misconstrue some of the questions that people are asking. When people are asking you questions about your payload, they're not trying to poke holes in your research. They're not trying to say that you didn't do a good enough job. They're just trying to make sure that every little aspect of your payload idea is being researched. Those questions are being asked. So if we submit a proposal to NASA, if NASA has any questions for us, we have those answers ready and already answered for them in the proposal, and that we don't send something into space and just are missing out on something. So like, just a reminder that the questions that we ask, especially as we go into these difficult questions that we're going to try and ask in the breakout rooms, it's in a constructive sense, and try and be constructive when talking about this, and hopefully we can poke holes in things, destroy your arguments, so that we can build them up to better, well-rounded ideas that are more likely to be accepted and work in space.
That's exactly right.
I'll get off my soapbox now.
Wait, how do we go back? Shoot.
The arrow keys might.
The arrow keys are down. Okay.
Yeah.
There you go. It's a little Veritasium video today.
Yeah.
Wait, is my sound shared? I don't think it is.
This is such an awesome.
Okay, well, we'll see you guys in like 10 minutes or so. Take a little snack break, whatever you need to do.
Experience to get up close and personal with the Curiosity rover. I mean, this isn't the exact one that's on Mars, obviously, but it's basically identical. I'm here at the Jet Propulsion Lab in Pasadena, California. I don't know how we got in here, Bill. It's amazing. This is the NASA center that's famous for building things like the Mars rover, space probes, and rescuing Matt Damon from the Red Planet. You guys must get pretty sick of answering questions about the Martian. Yes. This is project scientist Ken Farley. I spoke with him about life on Mars. He's one of many scientists working on the first NASA mission in 40 years, designed specifically to look for life on another planet. It's called Mars 2020. If there were life on Mars, wouldn't we have found it by now? No, we would not have found it by now. But we've been looking. There's been a number of missions like the Viking landers and like Curiosity, for example. Part of the problem is we're not even sure what we're looking for. Life on Mars may have been completely different from life on Earth. Recent missions like the Curiosity and Exploration rovers looked for and found evidence of water, a key ingredient for life.
Follow the water. Where was the water and when was the water? And then looking for habitability, looking for places that could have supported life. Now we know enough about Mars to look for ancient life instead of anything on the surface of Mars today.
There's no life on the surface of Mars today.
Most likely, if there is life on Mars today, it would be underground, underneath the ice caps, in places that are very, very hard to investigate with the sort of rovers and landers that we've sent so far.
So we're talking like moles, groundhogs.
Well, microscopic bacterial moles. No, not actual moles. We're looking for, we call them biosignatures. It's a pattern or a substance in the rocks that can only have been formed by life.
To find those biosignatures, the 2020 rover is going to need cutting-edge technologies developed here at JPL. But for definitive proof of life, they'll need drill samples.
We need to take a core that's about the size of a piece of chalk. We have to collect 37 tubes like this that will ultimately be laid on the surface of Mars for possible return in the future.
Mars 2020 is different from past missions because now NASA will need to bring those samples back to Earth to test them for evidence of life.
If they are brought back to Earth, we will be able to use all sorts of different kinds of techniques, many of which have not yet even been invented because nobody has been posed with this question.
So in order to find life, we'll have to return those samples from Mars, something that's never been done before, and test those samples with techniques that haven't even been invented yet. So I had to ask, how good do you think your chances are of finding life?
I'd say they're poorer than even, just because I remain skeptical. Regardless, we will learn about what the early history of the solar system is like, and that's the same environment, the same solar system that Earth was in when life was evolving. If you want to understand the origin of life on Earth, because that's the only place we know life exists, the rocks that recorded that are all gone.
So in a way, looking at Mars is like looking at a version of Earth frozen in time right about when life would have sprung.
That's, I think, the most exciting way to look at it.
It's just unbelievable. The stuff that is happening here is just so far beyond anything else. Like, what are you doing today? Are you sitting in your cubicle? Are you working on your computer? Okay, these guys are working on a freaking machine in outer space on Mars that is trying to discover life. This is cool. That was one of my field pieces from the Netflix show Bill Nye Saves the World, on which I am a correspondent. If you haven't seen it, you should check it out. But obviously, because that show is for a broader audience, I don't get to go into the kind of crazy detail that I sometimes do on this channel. For example, this image is the first ever beamed back from the Martian surface. It was taken by the Soviet lander Mars 3 on December 2nd, 1971. After becoming the first man-made object to make a soft landing on Mars, that lander transmitted data back to Earth for just 14.5 seconds before going quiet. And no one really knows what happened to it, but it might have had something to do with the huge dust storm that was taking place at the time. Now, this is the first clear image sent back from the Martian surface. It was taken by the Viking 1 lander on July 20th, 1976. And one of the stated aims for that mission was to try to find evidence of existing life on the Martian surface. And there was this experiment called the Labeled Release Experiment, where a scoop of Martian soil was taken and then a dilute solution of nutrients was added into that soil. But in those nutrients was the radioactive atom carbon-14. And the idea was, if you tried to detect the gases around the soil, if you detect some radioactive carbon dioxide, you know that the nutrients were broken down by something in the soil, presumably something that's living. What was remarkable about this experiment was that it got a positive result. There were a few other experiments trying to detect life in other ways, and they failed to get a detection. But this one detected radioactive carbon dioxide. And what's even more impressive was the Viking 2 lander, which tried the same experiment after the Viking 1 lander. It also got the same positive result. So things were looking promising. But then, about a week later, they tried to rerun the experiment, add a little bit more nutrients to the soil and see if you could get more CO2. But they couldn't. There was no additional CO2 released. So based on these negative results and the negative results of the other experiments, most scientists have concluded that there is no surviving life on the surface of Mars today. So how is the CO2 produced in the first place? Well, chemists suspect that very highly oxidizing chemicals, things like perchlorates, exist in the Martian soil and would have reacted with the nutrients producing the CO2 to start with. But once those chemicals are used up, well, there's nothing for those nutrients to react with, and so we get no CO2 the next time the nutrients are introduced. This story highlights just how difficult searching for life is using only remote instruments. And that's why for Mars 2020, they're going to create some rock samples that should be returned to Earth, if only they can get the budget for another mission that will go back and pick them up. But the rover they're sending in 2020 will also have some new tools on board that will allow them to look at rocks in finer detail than ever before. One tool, called Pixel, will use X-ray spectrometry to try to detect chemical elements with a spatial resolution that goes down to the size of a grain of salt. Now, what they'd be looking for are layered structures, similar to stromatolites found here on Earth. Those are mineral deposits which get built up by billions and billions of tiny organisms. So you're not really looking for fossils or for tiny little, microbial evidence. We're looking for the structures that they would have produced, layered structures. That's how we know about the oldest life on Earth, and so it's logical to think that's how we might find out about this old life on Mars. And the job of finding evidence of past or current life on Mars is made even more difficult by planetary protection. That's the principle whereby we should not introduce any life from Earth to these places where we're studying, like Mars. And that's completely understandable because, the worst discovery of life we could make on Mars would be life that we introduced there by our spacecraft. Certain organisms are really hardy, even in the vacuum of space and even when bombarded by radiation. But due to this constraint, spacecraft must be strenuously sterilized, and also they're restricted from landing near sites where we think there may be liquid water. I'm really looking forward to the results of the Mars 2020 mission, and hopefully a later mission where we actually go back and collect the samples that were placed there. But one thing that really struck me from my interview with Ken Farley was when he said that Mars is really like a time capsule of the rocks that Earth had when life evolved here. That's a way I'd never really thought about it before. But of course, because of plate tectonics and all the weathering that have taken place on Earth, we don't have the rock record from when life was first evolving on this planet. And that makes Mars a really good place to look not only for new forms of life, but also for an understanding of how life on Earth may have begun.
As soon as you guys get back, if you would want to turn on your cameras so that we know we have everyone.
John, are these all the questions?
These are most of the questions, unless you have more ideas for questions. I know we talked about some of them, but.
Yeah, let's throw one on about the atmosphere. So we have a vacuum in space, right? And we don't have the oxygen. So just whether it would survive in the atmosphere since it's so different from here on Earth.
Yeah, that's a good idea.
You know, because the atmosphere in space is different from the atmosphere in the ISS as well.
Mm-hmm. So we can do breakout rooms probably. Joel, I don't know if I'm the host anymore. I think I hit something to try to make you like the host, and now
Yeah, you did make me the host, and I'm trying to go through and sort people out based off of their teams right now.
All right, cool.
The other thing we might put is, could we fit the experiment in a CubeSat?
Mm-hmm.
Because some great ideas you just can't get down to 10 centimeters cubed. And I think one of the things to think about when we say, could this fit in a CubeSat, is recognizing that you actually get less than 10 centimeters cubed, because we'll have all the other equipment that is picking up the data and transmitting it.
Definitely.
And maybe, let's see, yeah, what data? I think, you know, when you look at what data do we need to collect and measure success criteria, we probably should add, and what, I don't know if equipment's too strong of a word, but what material, maybe equipment, maybe materials, but what materials, what would we use to collect the data?
Yeah.
Or could we use? Yeah, because I mean, some stuff it's, you know, so like with Florida, they measured whether something was alive by putting a dye on it, and the dye showed up in different colors depending on whether it was alive or not. And so just realizing that it's not, we won't be able to do simple observation.
Yeah, that's a good question.
All right. Yeah, and these were just some sample questions just to make sure, or to give everyone an idea of some of the questions that they might want to ask. But
Right.
hopefully each team generates some questions to come back and share with the entire group. And then we'll send everyone away this week with some of those good questions to have answered for next week.
Yeah. So you can look at these questions and they may feel overwhelming. You don't have to know the answer to it right now. This is just to make sure we're asking these questions. Some of them won't be like how do we measure things? Some of that won't be fully answered even until we're into the design. It's just us trying to check all the boxes we can so that to minimize the chance that when we get it all put together, it is something that we can launch and have a good CubeSat. So don't feel like, oh, we don't have that answer now, or oh, we won't have that next week. Just, look at what are some of the key ones, or if we don't know, we need to start thinking about, okay, well, what might we do and get creative, or even who might we need to bring into the discussion, who might help us answer it.
Mm-hmm. All right. And I have the breakout rooms ready whenever you want to kind of split people up, John.
Okay. Right. Wait, what do you mean? Like, you want me to split people up?
I know. I have them ready and split up kind of half and half, I think, between each team.
Okay. Yeah, 1 second. I just got to write down 1 or 2 of these questions.
Okay. Absolutely.
So you mean just when he wants to open the breakout rooms?
Yeah.
Okay, yeah.
I don't know. Has everyone gotten a chance to kind of read over some of those questions for your breakout rooms?
Joel, what we could do is have, like, if you're in one of them and I'm in the other one, and, like, we both want to share a screen with this PowerPoint. That way we could have them up.
Yeah, absolutely.
We can go into the breakout rooms now, probably.
Okay. If you're in breakout room 3, don't go into a breakout room, just so you know. But they should all be open now. All right. So you guys that are left, I didn't put you in one of the 2 breakout rooms, just in case you didn't want to go in one. But would you guys like to go into one of the breakout rooms?
Sure.
Okay.
I think I'll hold back. I think I have to do grading.
Certainly, yeah. And I didn't want to just put you in there without asking.
No, I appreciate that.
That sounds good.
Did I'm fine, so I'll stay with Karen, so to speak. But I got some ideas that I'll share with you guys a little bit later.
All right.
Joel, how long do you anticipate being in breakout rooms?
Probably only about 10 minutes this first time. Then we will go back to breakout rooms for 10 minutes and hopefully come back a couple times to share what we have and switch up breakout rooms once too.
Okay, great.
All right. That sounds
Sorry,
good.
Karen, I can't help you grade. I just do smiley faces.
If I could just throw a grade on and not give feedback, this would go so much faster.
You should have became a first.
Okay, here's a perfect opportunity to
Hi there, everyone. Did I
Hello.
miss out on anything yet?
No,
No.
no, I have not.
Okay, that's good to hear. So these are the questions that we were talking about beforehand. So I don't know how much we explained before we sent people to breakout rooms, but just to like reiterate things. Next week we will be probably deciding the payload. At least that's kind of our goal for right now. And we want to be able to make sure that we look at all aspects of the payload. So we're trying to come up with some difficult questions for the two teams to come up with. So we want to make questions targeted at your own team and as well as the other team. And you can really like make them difficult because, yeah. We don't have to have all the answers to the questions now, but just coming up with a list of questions to send everyone away with for this week. So does anyone have any questions that they want to add to begin with?
Can I give just a general question?
Certainly, yeah.
So, with the PowerSat, we already know that perovskite is better than default solar panels, and we know it can survive longer periods and that it can survive in space. So what's the end goal of this experiment?
Basically just see how much power it'd get in space, and well, I guess we know it'd most likely survive in space since of that test. But it'd be like, could this be viable to power a CubeSat or a rover or something?
It's more of just like the viability of the it's just more like the viability then, right?
Yeah.
Okay, sure.
Space, because they've tested it like in Earth efficiency, and they've like tested that it can probably survive space, but they haven't tested them together, and both of those factors can impact it.
Mm-hmm. Yeah. And I guess, do we know for sure is the, I thought to my knowledge, they wouldn't necessarily last longer in space, but they might last longer in space. From what I've seen, the perovskites, they decay in like 1,000, a lot of them decay in like 1,000 hours, but they've gotten some to last like a year.
I'm gonna say something along the lines of it didn't lose any efficiency for 420 days. So that's not a lifetime of 420 days. It was 420 days before they saw any decay whatsoever. But I'm not sure what he was referencing exactly.
I have that. I can pull up what he's referencing.
Okay, great,
it's
great.
I think it's on one of the Slack channels. Let me check.
Mm-hmm.
How long is the lifespan of a CubeSat?
I think it depends on what you're testing. I think at most it has to be less than 25 years. But I don't think we'd have it up for 25 years anyways.
Mm-hmm. Yeah,
And
a
with
lot of them. Go ahead.
With the 142-day efficiency, was that on Earth? Like it was on Earth, but were they like closely monitoring it and keeping it clean?
That's a good question.
The article.
Mm-hmm.
I guess I could send that to anybody who wants it. There's 2 articles. One's 11 pages. One's 9. So I can send that to anybody on Slack who wants it.
I guess I'll take it.
Yeah, I don't know. I guess part of this would be maybe not trying to answer them all right now, but trying to, excuse me, I don't know what happened there. Trying to just come up with a question so that the individual teams can come back with these answers for next time. But like if we were to put that into a question format, would we say like what are more details behind the efficiency? Or how would you think we should word that?
Don't word it more details behind the efficiency. I don't think, because that is on. I think that's on one of the slides pretty well already. maybe you could use more details, but
Yeah. Maybe like what were the conditions of previous testing, and how does that, and how will real life situations affect the efficiency?
Yeah.
Okay.
One of the things that was brought up yesterday, me, Andy, and John were having a Zoom meeting yesterday, and one of the things they brought up is just putting plastic around the pervious guy. It makes it last longer.
Certainly, yeah.
Can I ask another question? Isn't there like a bit like lots of space like garbage around Earth? Would the CubeSats be near that? Because that might slow up the decaying process.
That's a very good question. I don't think I know the answer to that. I don't know what anyone else does, but I think there is a lot of garbage, but I don't know if we'd necessarily run into any of the garbage, and I don't know how that would affect that. That's a great question to have for next time. Yeah, are there any other great questions to kind of think of for next time?
For the fungi team, how would you get it?
How would we get the fungi?
Yeah, because you'd probably, one of the things is you'd have to get special permission if you go to Chernobyl to get, because there's a rule where you can't take anything out of Chernobyl or touch anything in Chernobyl.
Yeah. So it's actually a fairly common fungi that you would like find growing like in random places, but it's just the prominent fungi that survived at Chernobyl. But there's also like different genomes and stuff, so there's definitely some more research behind that.
Can I ask some questions regarding the fungi one also? I thought this was just the power sats. I wasn't sure.
Yeah, I definitely kind of did mess up the breakout rooms. Gavin is on the fungi team, and Caleb as well, right? Yeah.
Should I hold my questions for fungi team, or should I just ask them?
No, please ask them.
So
yeah, you can ask them.
Okay, so the first thing that I was wondering about is based on the previous test done with a similar fungi where they determined that a 2 millimeter thick sheet of this living fungi could decrease the radiation by like 8% or something like that. So like Karen said, we're gonna need a way to measure the radiation both inside of and outside of our fungi shielding. So do we need 2 sets of sensors? Are we going to have a mechanical arm to move the sensors, or are we going to test it and then grow the fungi up around the sensors? Like that whole process of a control versus the experiment, I don't understand. I think we probably just haven't thought about it yet, but we need to think about how that's going to actually happen. Additionally, one last thing is the last experiment was done in the ISS, so a zero-G environment. And while their plans they're outlining were for like you put this stuff on the inner wall of your craft as opposed to the space environments, the CubeSat will very much be a space environment. So if the fungi can't survive space environments, which I think it's fair to say that it probably can't, do we have to build a container that can provide a more livable environment, or do we need to create that as well, or can we buy that somewhere?
I was thinking more for the experiment, like what if we did put sensors on the outside or like outside the fungus protection zone, but we didn't put sensors like in the middle of, so the fungus would grow around and see how it changes.
Mhm.
We'd have a control group.
Yeah. And similarly, since we might, I guess, have 3 CubeSats being launched together, I'm sure it would be another great way to, get that control, that standard data, if each of the teams had a way to measure radiation. And I believe the North Carolina team may have been trying to get a more accurate measure on radiation using hydrogel as sort of like a cloud chamber. So that might be a potential area as well.
That's a good point.
That's a good question that definitely needs to be answered by the fungi team in the future. Any other questions? I think I'm going to close things up pretty soon. All right. Any other questions?
I think for the solar panel team, would the solar panels be on the outside? Would they need to be protected, like when being launched up through the atmosphere at such a high velocity?
Yeah, I think it's a great question. Does anyone know the answer to that right now?
Hey, can you repeat the question? Or I'll just do it right now.
Sorry. Are the solar panels on the outside of the CubeSat? Because if they were, then would there need to be lots of protection for like when they're being launched through the atmosphere at such a high velocity? Because oxygen and
actually, when we're launching, when we're being launched into orbit, the CubeSat will be contained inside of a greater capsule. So nothing we're sending up will have to actually experience the sort of drag and thermal forces that are associated with launching through the atmosphere. I mean, eventually orbital decay will, send us back burning through it at the end of the mission. But when we're going up, we're going to be protected by whoever's sending us up will protect us on the way up there.
Yeah. And sorry if I wasn't talking too much there. I was trying to type a few things down. Yeah, are there any other questions before we kind of go back to the main session? No? All right. I'm going to close all rooms then, and I'll see you guys all back. All right, it looks like we have more people in here, but there still are some people in the breakout rooms. They should be back pretty soon. All right. Hey, John, do you want to kind of lead things through the questions that your team had, and then we can kind of break things up again?
Yeah. So our team kind of started addressing some of the questions just so we could see if there were more questions. and we didn't get through all of them, but a couple that we came up with was one amount of cost, because like I think that's something that's kind of been on the back burner as we've been researching this. Like we've looked at a little bit of cost, but if we're gonna really choose a payload, we should probably hammer down on that exactly.
Mhm.
And then the second question that was brought up was storage time, like especially for the mushroom sat. Like, how is this thing going to survive if we don't launch it for like it was sitting in the clean room for a month or two?
Certainly. Any other great questions come out of your room?
Not that I can think of, unless I'm missing something, guys. What about yours, Joel?
Yeah, so does anyone want to share some of the questions? I know, Robert, you came up with a couple good ones. But I actually don't see him on the call anymore. But yeah,
I'm
I
here.
can. Oh, you there? Oh, you're right under me. That's why I couldn't see you. All right. I know you came up with some good questions. You want to share some?
Sure. One of them was for the fungus group. How would you get the fungus?
Yeah, that's an important question that we need to do some more research on. Does anyone else from the team have any questions that they wanted to share? I have them written down, and I can just kind of run through them. So one of the questions for the background data that we kind of talked a little bit about when the fungi team was presenting was what data we would need for making sure it's a successful experiment. So that's the background data potentially, and the data that's shielded from the fungus. So would we need 2 sensors or something that moves, or the fungi grows around the sensor? Just a little bit more thinking on that side of things. Again, with the fungi team, what type of container would you need to make sure that the fungi would survive? The first experiment was on the International Space Station under a lot of different, life support, you would say, and what type of life support do you need for sure, or what can you not include? And then for the solar panel team, what type of containment or moving the solar panels around would you need to make sure that it survives the journey into space? And that kind of ties into when you go into space, are you expanding your solar panels, and what type of difficulties lie along that?
Mhm.
I guess one last question for the solar panel team again. What were the conditions of previous testing with the solar panels? Like, were they on, I assume they were on Earth, but were the people constantly like cleaning off the solar panels, making sure that they're in an ideal circumstance? Or were they exposed to like real life conditions where there's sometimes dust? And how would these real life conditions affect the outcome of these solar panels?
Mhm.
Now, I think I moved people around a little bit in the breakout rooms. Hopefully we have some different people with some, we have some different groups where people can ask some other people some different questions and kind of, come up with some better questions that ask again. But if the teams aren't split up very well, which it's kind of hard to tell by just looking at them and throwing some people around, but we can move some people around once we get into them. But we'll try and do this real
Joel,
quick.
Sorry,
Yes.
Joel, for this next breakout room thing, are you thinking that like we split up teams differently, or that we go into our own teams so we can start planning?
I was thinking we would just like rearrange the people so they're still in like intermingling with both teams, but if you think just going into separate teams would be more useful.
That's,
I don't know.
I mean, yeah.
Mhm.
I mean, I think we got a lot of good questions already. I was thinking, like, in order to plan for next week, we probably should go into breakout rooms, especially so we don't keep these people to like 12:30 again, like last week.
Yes, that makes a lot of sense. All right, I'm going to move people around real quick and probably get some people wrong. So breakout room 1 is going to be the fungi team, and breakout room 2 is going to be the power set team. If you're in the wrong room, just stay in the main room for now, okay?
Did you say number 1 was fungi?
Yeah, and number 2 is the power team.
Wait, are we splitting up or going into our own groups?
Yeah, into our own groups. To kind of
Then you
plan.
put me in the wrong one.
Yeah, I haven't moved most of the people around yet. All right, there you go. All right, I think I got everyone right now.
You got me the wrong one too.
Aja. Did you wanted to be on the fungi team, right?
Yeah.
Okay, you're in 1 now. You should be able to join that one. All right, I'll see you there in a second. All right. Yeah. And Ben, I want to just say thanks for stopping by today into the call. We hope to work with you a little bit more in the future. And yeah, excited to continue.
No problem.
Yeah. All right. All right. I guess what work do you think needs to be done this week? I'll just ask all of you guys that right now.
I guess look at all the questions we were asked today.
Mm-hmm. Yeah. So I know both John and I wrote some stuff down. Did anyone else write any questions down? No? Okay. Yeah, John and I will make sure those get sent out to everyone. So we have those
Maybe
questions.
put them in the Slacks.
Yeah.
Put them in the Slacks.
Yes, we can put them in the Slack. Probably the general Slack and then all of that. But I guess just some of the questions that I have, if we wanted to divide them up already. How would space garbage affect the CubeSat? Because there's going to be some. I don't know how much we're going to run into, but if someone wanted to look into that, that'd be awesome. Does anyone want to look into that?
Where does the CubeSat orbit in Earth? Do you know that?
It's classified as low Earth orbit. I couldn't tell you off the top of my head what height that is, but I think that'd be a great thing to try and find out as well.
Mm-hmm.
Do you want to do some of that research, Gavin?
Sure.
It's I just looked it up real quick. It says it's like about 2,000 kilometers or less.
2,000 kilometers or less. All right.
I looked something up. It says 70% of space junk is in low Earth orbit.
Yeah. So that's definitely something to think about. And I don't know what's the likelihood that you're actually going to run into something. I know our orbit is going to decrease faster than if we were way high up in space, but that's okay. Yeah, so you probably want to find some information behind that as well.
Because if we do run into something, then it could damage the fungus.
Certainly. I know I had kind of tried to work with Elsa in the past to find where we would get the fungi, and I think we found it's a fairly common fungi that just exists most places. But the question is, are there specific strains that would work better? And I think that's a pretty hard question to answer that we might just have to put, like, we don't know yet. I don't know. If someone wants to take that research or that question and do some research on that, that'd be great. But the answer's probably going to be, it's kind of hard to find. We might have to work with an expert to find out. But does anyone want to research that? Do they feel very strongly about it?
I can check some places.
All right, that'd be awesome. And then I guess developing kind of our experiments a little bit more. Oh shoot, I got one of the breakout rooms wrong. All right. I accidentally didn't put Casey in here. I put her in the wrong one, but she should be here in a second. For developing the idea a little bit more, where we need to put sensors, if we need more than one. I think Dylan and Gavin, didn't you do the experiment slide? Like, what is the experiment this past week?
Yeah, we did that one.
Do you guys want to kind of continue with that this next week and do some more research on that side of things?
Sure.
Yeah. And like the key thing, like they kind
One
of
thing
talked
about if we,
or what were you saying there?
one thing that would help is to like reach out to like people who are like knowledgeable in the fungus field or like radioactive devices.
Certainly. And we can definitely connect you to those people. We have connections actually for both teams already, kind of picked out, but we didn't want to reach out to them until we have like decided one of them or one of the payloads, just because we didn't want to go to someone and say we would like some help on this and then end up actually not reaching out to them and like not working with them in the future. But we definitely have those connections, and if you have like unknowns, it's perfectly okay to say these are unknowns, but we have a plan for connecting them. All right. And then what about I know this one is a really difficult question that has so many parts to it, but kind of like the life support side of things. And I think, wasn't it, Caleb, I asked you a little bit about if you wanted to be kind of the, if you kind of wanted to investigate some more research on, like, especially what it needs to survive in space like that, and just kind of coordinate some of those things.
Yeah.
Yeah. All right.
That research paper that I found, I feel like there's something there we can probably use, but I have no idea what any of it is saying.
Certainly. Yeah, and that's okay. Like that's going to be another one of the things that we're going to need to talk to people with. But if you can kind of lay out categories a little bit better, that would especially help. All right. I'll be right back, guys.
Casey's hanging out with us, and she sees me way too much, Joel.
Yeah, she's been assigned to breakout room 1 for a while now. You might have to go down and manually select it in the bottom now.
Oh, right here.
Okay, yeah.
Bye, Case.
Yep.
Bye.
I'll see you in a second, Casey.
That was better.
It makes no sense, though.
No language makes sense unless you know the language.
That's true.
Spanish, everything is grammatically correct.
Je suis la Chypre. That's French.
You have more accents in French. It's more interesting to write.
It's more confusing to write.
It's more fun to say.
Je m'appelle.
Because it's less like English. It's more fun to say.
That's what French is like.
Yeah, I feel like in French, you're bound to like swallow your tongue and or spit on someone because of your enunciation. I don't
At least
know.
it's not German. German's the worst. Or no, the worst language is Klingon. Even though it's not like a real language, it's a full language, but it's not spoken by anyone. But it's totally the worst language to like spit at people.
But speaking Latin, like just speaking Latin the rest of the day.
But why?
No. Without Latin was dead, because it is.
Yeah, Latin's a dead language. No one likes Latin.
But people still study it, and like if you know all your
I know.
Latin roots and stuff, it is so
My mom studied
helpful.
Latin.
Really?
My mom studied Latin. I'm just like, I don't know. I'd rather study French. My stepdad speaks Spanish, but I still like French.
I mean, those are all the Romantic languages, so they like come from a common origin, don't they?
Yeah,
Derived
I
from
think so.
Latin? I don't know.
Yeah.
Yeah, just kind of to sum things up for the meeting side of things. So we have some of the questions. We divided up some of the work, but we don't have a ton of questions. So I don't think everyone has like a specific question to answer, just a few people. Once John and I kind of compile some of the questions, send them out to each of the sub-teams, we will kind of divide a little bit of the work to make sure that individual people have something to do this week. But overall, it's just, trying to do a little bit more detailed research, trying to answer some of those difficult questions. Because next week, if I can bring up the slide again, because I think it's a cool, funny picture, we will have some NASA scientists, as well as some old members of the aerospace team that now work in industry who have so much more experience than like John and I do. Have some of them ask you really difficult questions to make sure that your payload is feasible. And we want to make sure that we can answer some of those intelligently. And it's perfectly okay, like a reminder to say, we don't know yet, and we don't know for sure. Because it's always better to have that as your answer than to try and, make something up along the way, right? I mean, not always, but in this case, yes. But yeah, I don't know.
I feel like we should just continue research on the topic and what we've already done.
Certainly. And if anyone finds anything notable to share, just go ahead and send it in the Slack channel, and we'll hopefully have some other people check it out as well. Yeah. And Casey, it looks like you're raising your hand.
Yeah, I have a question. When's our next meeting for this week? Because it's usually on Wednesdays, but I can't make it on Wednesdays.
Yeah. That's a good question. If we wanted to talk about that right now, that'd be fantastic, actually. We never really set a normal meeting time, I have to say. If we wanted, like, during the week, just kind of when anyone can hop on and what's a good time. I have to say, I work a lot. I have a lot of school things going on, and it's perfectly okay if you guys want to meet without me, but it'd be great if we could meet with me. But when works well for you guys? So if Wednesday doesn't work well, that's perfectly okay. What about Tuesday or Thursday, and at what times?
Really any time, but it'd be better in the evening around like 6 to 8 because that's when I probably don't have anything going on.
Mm-hmm.
I'd say Tuesday, Wednesday, Thursday, at least after 5 o'clock.
Mm-hmm.
Anytime works, but like Wednesdays after like 6:30, I can't do, or 6, I can't do it.
Mm-hmm. It makes sense. So
Thursdays probably like 7 or 7.
What about Tuesdays at like 5? Like 5 to 6 on Tuesdays. Does that work for you guys?
That should work.
Yeah.
Okay. Well, I'm going to... Ooh.
Caleb says we can't.
I can't do 5 to 6.
Yeah, on Tuesdays. So Caleb
Yeah.
and Casey? Hmm. See.
I could do it. I just might be a little late.
Mhm.
I can do it 6 to 7.
Yeah. If that works better for you guys, 6 to 7, I won't be able to make it to most of that. But kind of at the end of it, I might be able to hop in.
You could always just start the meeting and leave.
Yeah, and I can have it set so you guys can join the meeting like at 6 without me in there. If that works for you guys. Or if you guys want to meet on Monday, I don't know if that's too soon, but 6 to 7 or 7 to 8 on Monday would work for me if that's something you guys want to do.
Yeah,
7 to 8 works for me.
That's good
Does
for
that
me.
7 to 8 on Monday?
Yeah.
Whenever.
Yeah, that works.
Okay. Would you guys be okay with 6 to 7 too?
Yes.
Yeah, probably.
So Elijah says 7 to 8 would be better. What about 6:30 to 7:30 to kind of split the difference?
I might not be able to make that still because my family eats around 6.
Okay, that's fair. 7 to 8 will work. I might have to hop off a little bit early because I have a meeting at 8 that I have to lead every Monday. Yeah. Does that sound good to everyone though? All right, 7 to 8 on Monday. I will go ahead and send a link in the Slack. Once I get out of this meeting, but yeah. But yeah, just to reiterate things, I think both of the teams honestly did a great job this week. I was really impressed with some of the work that you all did, the presentation. I thought it was, good work, and hopefully we can do some of this same great work going into next week. But yeah, I don't know. Does anyone have any kind of closing thoughts?
The next icebreaker should be why Spanish is so much superior to French.
Or which one is
Looked up 20 countries have Spanish as an official. Well, 29 countries official in it.
Good for them.
So that's a point for French.
Well, Mandarin Chinese is like the hardest language I've found to learn.
Well, like Mandarin Chinese has like nothing to do with English, but like at least French and Spanish, they're derived from Latin.
A language is only as hard as your first language.
Yeah. English
So,
is one of the hardest languages, I think, because we're so different from everyone else.
Mm-hmm.
What's nice about English is you don't have male or female, masculine or feminine pronouns.
Yeah, you don't have to remember as many words.
There's no L's in laws.
Yeah.
Well, yeah, there's not gender specific pronouns, but for
it's all just the.
Yeah, it's just instead of lay.
I think I think Spanish as a language makes so much more sense than English.
And French.
I don't have enough experience with French to say anything about it, sadly. I have a friend that's a French major though, and she's really awesome. Yeah. I'm actually gonna hop off because I have to make it to another meeting and do some work before the meeting. But if you guys want to stick around and hang out for a while, that is completely okay with us. Okay. All right. See you guys later. I'll see you guys on Monday at 7 then.
Yep.
All right. See you guys.
See ya.
All right. I have to make someone the host. Does anyone want is someone going to stay around for a while?
I'll be leaving soon, so not me.
I have to get off to go eat.
Okay. Yeah, that sounds good.
All right, bye.
I will just make.
Thank you.
Yeah. See you guys.